welcome to Iteration. Just before we start, just a reminder that there is a notes jotter available for this video. Just check the description below for a download link and you can work along with me as we go through the video. So to begin with, we need to actually think about what does iteration actually mean. Well, iteration is a repeated process which hopefully improves our outcomes. So it's using the same formula or the same equation over and over again to keep improving our estimate to an answer. Now you may be wondering why there's a picture of a rabbit. Well, this is my best analogy of what iteration is. A rabbit eats carrots, and after it's eaten a carrot, what does it do? Well, it poops them out. And if you know anything about rabbits, you may know that they actually eat their own droppings. And the reason they do that is that there are still nutrients involved that they didn't quite process the first time round. And so they eat those droppings, they go back in, they eat them, and they drop them back out again. So what's actually happening here is an iterative procedure. They have taken an input of the carrots, and they produced a result, an output, but that output isn't as good as it could have been. And so it goes back into the system to go through the process and to make a new output. And so what we're actually doing here is we're just keeping this repetitive process, putting our output back in to see if we can get the best possible result. Now, iteration is a method of estimating a solution to an equation. And so the first thing is we need to work out where the solutions may possibly lie. And to do that, the first thing we do is we just check between two values to decide if there is going to be a solution. And to do that, we've got in this question, show that the equation x cubed plus 6x equals 2 has a solution between 0 and 1. Well, the way that we're going to do that is we're just going to use a bit of substitution. So we're going to place each of those values into our equation and see what happens. So in the first case, we have 0 cubed plus 6 lots of 0. Now, if we work that out, 0 cubed is 0 and 6 times 0 is 0, so that is an answer of 0. If I use the number 1, well, 1 cubed plus 6 lots of 1, well, 1 cubed is 1, and 6 times 1 is 6, so 1 plus 6 is 7. Now, what you will notice here is the answer that we were supposed to get, an answer of 2. Well, 2 lies in between the two answers that we have found, and therefore this is our proof that there is a solution between those two values. Somewhere between 0 and 1 will be a solution to the equation. Let's try it with the next question. So show that the equation 2x squared plus x minus 5 equals 0 has a solution between 1 and 2. So the same thing applies. We're going to substitute in each of those values into the equation. And if you wanted to, you could be using a calculator for this. These questions are generally calculator questions. But 1 squared is 1, so 2 times 1 is 2, plus 1 is 3, take away 5 is negative 2. If I do the same with the number 2, so 2 lots of 2 squared plus 2, take away 5, well, that gives me 8 plus 2 is 10, take away 5 is 5. And again, if we have a look at the answer we were expecting, it was 0. Well, 0 is in between these two values. Now, this is also an important one. If it is an equal to 0 equation, what we're actually looking for is a change in sign. So we've got a negative here, we have a positive here. That change in sign is an indication that there is a solution between the 2 points. And so finally, the last one we've got is show that the equation 2x cubed plus 3x equals 3 has a solution between 0 and 1. And so again, all we're going to do is pop our two values into the equation and see what answer we get. So 0 cubed is 0 and 3 times 0 is 0, therefore we have 0. And if I place the number 1 into the equation, then 1 cubed is 1, so that's 2. 2 times 1 is 2, and 3 times 1 is 3. Put them together, we get 5, and the answer we were looking for was 3, and that is in between the two values we've worked out, and therefore there's our evidence that there is a solution between 0 and 1. So the second stage of iteration is to rearrange the equation so that we have what is known as an iterative formula. Now to do that, what we need to do is we need to make the original equation into an x equals equation. Now this could be done in many different ways. Depending on how you rearrange that formula, you could make different ones, but certain versions are just better. But what we look for in the question, we're always given a clue as to how we are going to rearrange. Now if we have a look in the rearranged version, we have an x cubed on the right hand side. So that is a suggestion that as we are rearranging, we want to first get rid of this x cubed. And so the first thing I'm going to do is I'm going to subtract x cubed from both sides. So 6x equals 2, take away x cubed. And then if I want to make x x all on its own, well, that would be dividing by 6. And so x would be 2 over 6, take away x cubed over 6. But we just have to take a quick check, is that the same as what we had at the top when we were given the question? Well, it said x equals a third take away x cubed over 6. Is that the same? Well, it is. It's just that what we've done is we've simplified this fraction. And so we've shown that it is possible to rearrange it. We'll do the same with the next equation. So we've been asked to show that the equation 2x squared plus x take away 5 equals 0 can be arranged to give x equals the square root of 5 minus x over 2. Now, in this case, the clue as to how we are going to rearrange is the square root sign. The fact that we've been asked to take a square root means that we must have been left with the x squared on the left hand side. So it is the x and the take away 5 that we first want to move to the other side. So we're going to say that 2x squared equals, well, I would need to take away an x and I would need to add a 5. So I'll add the 5 and I'll take away the x. And then the next stage of my working, well, I would want to get rid of this 2, so I'm going to divide everything by 2. 5 take away x all over 2, and then the last stage would be to get rid of this x squared, and the way to do that would be the square root. And so the square root of everything which was already there, 5 minus x over 2. And if we have a look, that is exactly the formula that we were given at the top. And our last one, we're going to try and show that the equation 2x cubed plus 3x equals 3 can be rearranged to give x equals 3 over 2x squared plus 3. Now, in this one, we are showing here that we want to divide by 2x squared plus 3, but if we have a look at our original equation, we didn't have x squared, we had x cubed, and we didn't have 3, we had 3x. And so in this case, the very first thing is that actually we have factorised that expression. And we factorised by taking a factor of x. So it's x brackets 2x squared plus 3 equals 3. And so now if I need to get x all on its own, well, all I need to do is divide by everything that was in the bracket. And so x equals 3 over 2x squared plus 3. And so we get to the actual iteration process itself. Now before we get into this, I'm just going to have a quick look at this formula, as there are a few little details in there which look a little bit strange. We have these subscripts. Now you'll be used to seeing numbers at the top of letters, as in our powers, but probably not having little letters underneath. Now I just want to show you exactly what this means. You'll see that this one has a subscript n and this one has a subscript of n plus 1. Now what this means is this is the nth x value. So just like in the nth term, n actually represents a number as in the first, the second, the third term in the sequence. Well, this is the first, the second, the third, the fourth value that we have tried in the formula. N plus 1, well, that just means it's creating the next one, so the one after that. So if we said, if we had x1, that would be xn, and it would create, by using the formula, n plus 1, so it would become 2. It would create the second value. All that means is that we keep putting those values in, so we then put the second one in, and it creates the third, and so on. And so don't be worried about these subscripts, it just means this is the value you already knew, and this is the one that you're going to create. Okay, so let's try and use the iterative formula in order to find an estimate for our solution. In this case, this is actually just the rearranged version of the equation that we started with, of x cubed plus 6x plus 2. And so what we're looking for is we're trying to find an estimate 3 decimal places, and we're going to begin with x0 equals 0. Now that just means the original value, so the first one that we're going to use in the formula. And so if I want to get x1, which would be my first result, then I need to use 0 in here. And so that is a third take away 0 cubed over 6. And all I'm going to do is I'm going to grab my calculator and type that in exactly. So 1/3 take away brackets 0 cubed over 6, and I get an answer of a third. Now a third is the exact answer, but we are looking for an estimate to 3 decimal places, so I actually want that as a decimal. It's going to be 0.33333 on and on forever. Now that is only the first result. I want to try and improve on that answer by performing the iteration again. So I'm going to go to x2, and x2 just requires me to use the value that I got in the previous iteration as my x value. And in this case, 0.333, it's very difficult to actually type into a calculator to do it accurately, but we have the benefit that we have a button called ants. So all we're going to do is we're going to go back to the original equation in our calculator and replace 0 with ants. And if you do that, it pops the answer that you already had into the equation and gives you the answer, 53 over 162. Now if I go to a decimal, let's just bring that back, 0.327327 ... That answer, we're looking here for an estimate to 3 decimal places. Now if we have a look, this one will be 0.333, this one will be 327. They are not the same. What we're looking for is a match. We want the same value to 3 decimal places to give us our estimate. So we need to keep going. x3. We don't need to type all of this again because it's already in our calculator. And the fact that ants is in there, it means it's now just going to use the answer we've just gotten. So let's press equals again. And it comes out this time at 3274. 3274. And on and on and on. Now, if we have a look at 3 decimal places, 327, 327, we have a match. And so our estimate for the solution would be that x equals 0 0.327. Okay, so we're going to try the same, starting with x naught equals 1 this time. For the iterative formula, xn plus 1 equals the square root of 5 minus xn over 2. To find an estimate to 2 decimal places for the solution to 2x squared plus x take away 5 equals 0. So again, we've been told x naught, that is our very first value. So all we're going to do in order to find x1, I'm going to place the value of 1 in for x. So I'm going to have the square root of 5 minus 1 over 2. And I'm going to put that into a calculator and find our answer. Well, if I do that, I get that the answer is root 2. Now again, root 2 is the exact answer, but it's not enough for us to find a decimal estimate. So we'll press the SD and we get 1.414 and this is our first possible solution, but we want to improve on that, and we'll improve on it by going to x2, repeating the process again. And so just as we did before, we're going to replace our value of 1 that we did have with answer. We're going to put the answer that we've just gotten into this equation, and so we'll just tap back and put in answer, press equals, and this time we get 1.338 ... Now obviously here to 2 decimal places we're a long way out, so we're going to keep going and try x3. Same thing, we don't need to type all of this in because it's already in our calculator, so we just press equals again. And this time we get 1.352. Now you will notice we are now starting to come closer together. We had 1.41, 1.33, but now we're getting a little bit closer at 1.35. So those values are coming closer together. So we'll go for another iteration. Again, we don't need to type it in. We can just go straight in and press equals again. And we get 1.350 ... And if we have a look, well, there to 2 decimal places is 1.35, and to 2 decimal places is 1.35. The fact that we've got a match, that is our solution. So x equals 1.35. And in our last question, starting with x naught equals 0.8, use the iteration formula xn plus 1 equals 3 over 2 xn squared plus 3 times to find an estimate for the solution to 2x cubed plus 3x equals 3. Now you'll notice this time we haven't been asked for an estimate to a certain number of decimal places, so that means what we're probably going to find here is we're not going to get an exact match. All it's asking for is for us to perform the iteration 3 times. And so what that means is we need x1, we need x2, and we need x3. And so we're going to perform the first iteration. It's going to be 3 over 2 brackets 0.8 squared plus 3, 0.8 because that is the value we've been given as x naught. I'm going to put that into the calculator and try and find an answer. So let's do that. So we've got fraction 3 over 2 brackets 0.8 close brackets squared plus 3, and we get an answer 75 over 107. Again, let's just switch that out to a decimal, 0.700 and so on. So 0.700 ... But that is only the first iteration. We've been asked to do it 3 times, so we're going to do the same again as we've done in all of the previous ones. We're just going to replace that with ants. And if we go back to our calculator, let's change let's change 0.8 for ants, see what we get. In this case it's 0.753, 0.753, and then we want to do the same again for our x3, and all we're going to do is press equals. And so we'll go back to our calculator, press equals again, and this time we get 0.7255. And this time, because I wasn't asked for a certain number of decimal places, I need to just make a judgment as to what I think is suitable. I'm going to go to 4 decimal places just so I'm really accurate in my answer. So 7255 to 4 decimal places. And so what that's saying is that in this case we've improved our answer one iteration at a time. Our original answer would have said around 0.7, but then we've improved that to 0.75, but then we've improved it even further. So our best estimate at 3 iterations is 0.7255. And so we come to the exam question. This came from the Edexcel paper in June 2017, and it was on higher paper 3. So there we go, it is a calculator question. And we've been told that using xn plus 1 equals -2 take away 4 over xn squared with x naught equals -2.5, find the values of x1, x2 and x3. And so what they're asking us to do is quite simply to use the iterative process and substitute in each value. And so in this case I'm going to begin with x1 at -2 take away 4 over -2.5 squared, and that is going to go into the calculator. So I've already typed that in. Let's see what the answer is. Well, it comes out at -66 over 25, but I want it again as a decimal just to be sure. So -2.64, -2.64. x2, how am I going to find x2? Well, x2 is going to come from just replacing my x value with what I already had. And so let's just write ants squared. And again, go back to our calculator. And all I need to do here is replace the -2.5 with ants and press equals. And it comes out at -2,803 over 1,089. But that is the same as -2.573 ... And then we want x3. I've run out of a little bit of space, so I'm just going to move over here. x3, well, all I need to do is remember that I just need to press equals again on my calculator. So pressing it again gives me -2.603. So let's just bring that across. So -2.60, and let's call it, it doesn't give us a number of decimal places, so let's just call it 4 decimal places. There we go. So -2.604. Part B. Explain the relationship between the values x1, x2 and x3 and the equation x cubed plus 2x squared plus 4 equals 0. Now, in this case, if we have a look back here, we just need to have a look at what this equation looks like. And does it have any resemblance to the formula we've used up here? Well, what we've actually got here is a rearranged version of it. Now, we don't need to show that it is a rearranged version, but just in case you're wondering, if we start off with x cubed plus 2x squared plus 4 equals 0, well, if we subtract the 4, we have x cubed plus 2x squared equals -4. We then factorise with x squared, so x plus 2 equals negative 4. We divide by the x squared, so x plus 2 equals negative 4 over x squared. And then finally, we'd subtract the 2, so x equals negative 2, take away 4 over x squared. That's just a little bit of proof that it is a rearranged version. It's not necessary in this question, but that's just there to show. But the first thing is that you must mention in an explanation that this is a rearranged version. Of the equation, because that is the first part of the relationship. And then secondly, we need to state what x1, x2 and x3 actually are. And so x1, x2 and x3 are estimates of the solution. And that's all that our iteration process actually does. It finds us estimates. Now they are improved estimates. As we keep working through each iteration, we improve those estimates. But those are the two relationships between x1, x2 and x3 and the original equation.